Hi, in 10.1, there's 3 objectives: identifying characteristics of circles, recognizing chords and diameters, and recognizing the special relationships between radii and chords. So by definition, a circle has a center point, and the circle itself is the set of all points that are equidistant from that center. The radius is the distance from the center to the circle. We can have concentric circles, which are circles that have the same center and on the same plane. If 2 circles are congruent, then they have congruent radii. I think we learned that in chapter 3. And then a point is on the interior of the circle or the exterior of the circle. Point C is on the exterior, A is on the interior, O is also on the interior, but it's the center, and then B is on the circle. A chord is the connection of any 2 points on the circle the segment lies inside the circle itself. A diameter is a special chord because it goes through the center of the circle. These are formulas that we've seen already, and we need to remember them, so they're being refreshed here. The area is pi times the radius squared. Remember, area measures 2 dimensions, so it's squared. Circumference is like the perimeter. It's just a length. So it's 1 dimension, so the exponent is 1. Circumference equals pi times the diameter. These are some of the axioms that you're going to need to remember. If the radius is perpendicular to a chord, then it bisects the chord. If a radius bisects the chord, that is not a diameter, then it's perpendicular to the chord. You have to say that's not a diameter, because otherwise you wouldn't have a radius going through it. And the perpendicular bisector of a chord passes through the center of the chord. We are going to skip some proofs, so let's hop over to what you would have received in class. Okay, remember again, we have the 3 objectives. Skipping the proof. If the radius of the circle is 13 millimeters. So now I'm going to draw in a radius of 13. I'm not drawing it perpendicular, I'm drawing in the whole radius. Okay? And the length of the chord is 10. The minute I draw the radius perpendicular to the chord, now remember that's not the whole radius. So I can't say that this length is 13. It's not. The whole radius is 13. That's why I put it over here. But I know that if a radius is drawn perpendicular to a chord, it bisects the chord. So this distance here is 5. And now we can use our triples. A 5 something 13. So x is 12.